In this section, we are going to discuss few numericals of wave optics. Your material, page number 204, question number 39. IIT previous year question. In Young's double slit experiment, the width of one of the slit is double that of the other. IM is the maximum intensity. Find intensity when phase difference is 5. See here, they gave it here. The width of one of the slit is double that of other. So I have written A2 equals 2 times of A1. A2 equals 2 times of A1. Next, what is intensity? It is proportional to amplitude square. Another main formula. If two waves are superposing each other, their intensity we can write as I1 plus I2 plus 2 root over I1 I2 cos phi. So from here I got the relation between A2 and A1. A2 equals 2 times of A1. So even the intensity I can write it as I2 by I1 is nothing but A2 by A1 the whole square. That is 2A1 by A1 the whole square. That is 4. So I will get I2 as 4I1. I2 is equal to 4I1 we are writing. Now the next one we should write here I2 and I1 values we got. In terms of I1 only we are getting. We should find what is the maximum intensity here. Maximum intensity is A1 plus A2 the whole square. So I can write A1, this one will be 2A1 the whole square. That is 3A1 the whole square. That is 9 times of I1 is your Imax. Now I am going to substitute in that equation I equals I1 plus what is your I2? 4I1 plus 2 root over I1. I2 I can write 4I1 cos phi. This I can write I1 plus 4I1 plus I1 into I1 and root. This I can write 4I1 cos phi. Here you have to remember your option is in terms of Imax and 1 plus cos square phi. So you have to check it how we should take the common terms. I can take I1 plus, if you take here 4I1 as common, 1 plus cos phi will come. This even I can write I equals I1 plus 4I1 into 1 plus cos phi, you can write it as 2 cos square phi by 2. So this I can write I1 plus 8I1 cos square phi by 2. So this is, you have to check it again with the option. Option is in terms of maximum intensity. So I am taking I1 plus 1 by 8 cos square phi by 2. This I1 I can write in terms of Imax, that is I maximum by 9 into 1 plus 8 cos square phi by 2. It's a very important question. In many exams they ask. The hint in the question is the amplitude of one of the amplitude is double that of other. And they are given in terms of a maximum intensity. So maximum intensity formula we should remember A1 plus A2 the whole square. So I just calculated my maximum intensity. After that I1 and I2 relation we have taken. Then this formula you remember, if two waves of different intensity are superposing, we will get I1 plus I2 plus 2 root over I1 I2 cos phi. Then we are substituting I1 plus 4I1 plus 4I1 cos phi. After this, even we can write it as this 5I1 plus 4I1 cos phi also we can write it. This option also correct only. But that is not there in the option. The same thing, I can write it as I is equal to 5I1 plus 4I1 cos phi also we can write it. If you take I1 as common, 5 plus 4 cos phi. Now, this is also correct, but you have to check with the option that was not there. Option is like this. So, you should, I am taking here I1 as common, then changing 1 plus cos phi, cos square. Here we are taking here 1 plus cos phi we are taking. 1 plus cos phi we can write it as 2 cos square phi by 2. Next. This is a theory question. It's a very important theory part. Two coherent sources, two coherent point sources, S1 and S2, separated by D. S1 and S2 separated by D. The fringes obtained are, the fringes obtained are. We know that we will get like alternate dark and bright bands, but the setup they gave it like this in this question. This is S1, this is S2 and this is D. This screen is perpendicular to line joining sources. Line joining two sources. In this case, you remember your fringes in the form of concentric circles. Your fringes in the form of concentric circles. Very important point. So what I told, if the sources are like this and the screen we have placed on the perpendicular to the line joining these two sources, your fringes will be form of concentric circles. But in Young's double slit experiment, we know that it is like a parabolic shape, hyperbolic shape it's coming. And it's very far, we take it as straight. The question is, in YDSC, intensity at a point is I by 4 of maximum intensity. Find angular position. Find angular position. In Young's double slit experiment, they are given here the intensity is 1 by 4 of maximum intensity. 1 by 4 of maximum intensity they are given in the question. So we should find here at which point, what is the angular position they are asking. So we have to take it in different form. They gave intensity. So you can just take it like this. I is 1 by 4 of I naught they gave. I is intensity at a point is 1 by 4 of I naught they gave. And we know that I is I naught cos square 5 by 2 is the equation. That is 1 by 4 of I naught. I naught cancel. Cos 5 by 2 is 1 by 2. And it is nothing but 5 by 2 will come as. What is 5 by 2 value? Cos 5 by 2 will come as 1 by 2 means 5 by 2 is nothing but 60 degree. That is 5 is nothing but 120 degree. 120 we can write it as 3 pi by 2. 2 pi by 3, that's better. 2 pi by 3 we can write for 5. After finding phi, they are asking angular position, theta we need. This is called the phase. This is called the phase difference. We have a relation with the phase difference and path difference. Phase difference is equal to 2 pi by lambda into path. So path difference we can find by, what is your path difference? Lambda by 2 pi into phase. That is lambda by 2 pi into phase is 2 pi by 3. That is lambda by 3. I got path difference. Then we know that normally the path difference is nothing but, if you take the Young's double slit experiment, see I am taking this point. So see, like this, if this is theta, this is nothing but d sine theta. That is the path difference. So path difference can also be written as d sine theta. So here we can write this is path difference, even this also path difference. I can write d sine theta is equal to lambda by 3 or sine theta is equal to lambda by 3d. What is the path of sine theta is equal to lambda by 3d. Next. The first diffraction minima, due to single slit diffraction is theta. Wavelength is 5000 angstrom. Width of slit 1 into 10 power minus 4 centimeter. Then theta equals, it's a very simple question. Only remember what is the condition for diffraction minima. Diffraction minima is nothing but A sin theta equals L lambda is the condition for minima. Simple, direct question only you should remember this. Then I can write here, we should find out sin theta is equal to n lambda by A. As it is a first minima, put n equal 1. 1 into 5000 into 10 power minus 10 by A. A is 1 into 10 power minus 4. Centimeter means into 10 power minus 2 meter. So if you solve 10 power minus 6, 10 power minus 10, that is nothing but 0.5, that is nothing but 1 by 2. Theta is equal to 30 degree. Next. A light of wavelength 5000 into 10 power minus 10 meter is incident on a slit. First minima diffraction is obtained 5 millimeter from central maxima on a screen placed at 3 meter from the slit. Find width of the slit. So here you see we are getting the diffraction minimum and all. Now if you are taking it like this, it's a screen, central point, you are taking a point here. This is your theta, this is your y. And see here, they are given the first minima is obtained 5 millimeter from central maxima on a screen placed at 3 meter they gave. First of all, you write the condition for first minima. What is the condition for first minima? A sin theta equals n lambda or A sin theta equals lambda. Here our question theta we can find. Sin theta is nothing but opposite side by adjacent side. So I can write A is, sin theta, or you can take here sin theta approx to theta. So theta equal to arc length by radius. Theta equals, I can take it as y by d equals lambda. We need A, lambda d by y. What is lambda here? Lambda is 5000 angstrom, 5000 into 10 power minus 10. D is 3 by millimeter, 5 into 10 power minus 3. So I can write these two, we can cancel. This we can write it as 1000. 3 into 10 power, this will go up 10 power 6 into 10 power minus 10. That is 3 into 10 power minus 4 meter or 0. They are given that in centimeter. We can write in centimeter also. This answer is correct. So what we did? Question, remember diffraction, what is the condition? Diffraction we can write sin theta approx to theta and theta is nothing but y by d. First minima condition A sin theta equal to L lambda. Here I did only one approximation. When sin theta approx to theta, y by d is nothing but sin theta we did.